This module helps us visualize various coordinate frames. All right. In this module, we have a few objects in a virtual world. Each of the objects in the virtual world has its own local coordinate frame, which are visualized by the red, green, and blue tubular axes that we see. So we have this little UAV right here, which has its own local coordinate frame. This local coordinate frame has a red, a green, and a blue axes. All right, RGB, red, green, blue, they correspond to the x-axis, y-axis, and z-axis, respectively. Similarly, there is a global axis, a global coordinate frame that gives us the origin of the entire world. So, right at this intersection right here is the global coordinate 0, 0, 0. This is just like the Cartesian plots that you've done in 3D vector calculus from undergrad. 0, 0, 0 is the center of our world. Now, the location of every virtual object in the world would have its location at the center of its axes. So if we go very close into the spaceship here, or into this drone, and we look right where these tubes intersect, right here, this is the relative 0, 0, 0 of this object. But the location of this point right here is specified in the global frame relative to that origin, which means if we take the point right here and subtract it from the origin, we get a vector that starts at the origin and points directly to this object. Therefore, the global translation or position of this object is defined relative to this origin. Whenever you're dealing with a virtual world, the position of everything is always relative to some origin. If you do not define an origin, you cannot define the position of anything. Similarly, the orientation of everything in a virtual world is dependent on the global frame. So when we're looking at, for example, this x vector right here, this x vector is the relative x vector, but its direction is expressed in terms of the global coordinate frame. We'll get more on that later. So, looking at this virtual world, let's define what we're actually looking at. Here we can see that we have our global axes. We have our global x-axis, our global y-axis, and our global z-axis right here. Then for every object, be it this floating runway right here, or this UAV, or even this miniature planet Earth, each object has its own local coordinate frame. All right, the next thing we're going to do is talk about how these frames are represented. The position of every single one of these objects, as we stated before, is always defined relative to some origin. So I've put a dot at the origin. And if I want to say what is the XYZ position of a particular object, let's say that we're looking at this axis right here. What is the position of this object? Well, we can do that by drawing a vector from the origin to the center of the object. All right? This vector that we see right here will have a component along the x-axis. Let's see if we can draw this in. It'll have a component along the x-axis. It will have a component along the y-axis, and it will also have a component along the z-axis. All right, so if we try to draw in, we'll fill in our dotted lines here. Let's see here. So we would have some dotted lines that would sort of represent something like that, and something like that. All right, so this would be the x component that tells us the distance along the global x-axis that this object resides. Similarly, the displacement along this y-axis right here tells us how far along the global y-axis this object resides. And lastly, the z component will inform us how far along the z-axis this object resides. The same holds true for every other object. If we look at our runway right here, this runway is actually a relatively large object, whatever that means, but we can see that its position is defined right at the center of its axis. And again, when I say, hey runway, what is your position? It will distinctly be the vector from the center of its origin, or from the global origin, straight to the center of the relative origin. And again, this vector will have an x component, a y component, and a z component, all of which will be expressed in the global coordinate frame. All right, that means that this x always corresponds to the distance along this axis. It'll either be a positive or negative number. The y value will always correspond to the distance along the y-axis, the global y-axis, and the same holds true for the z-axis. Right? So whenever we talk about a position of an object in a virtual world, we are talking about expressing it along the x, y, and z in the global axes. All right? This holds true until we get into hierarchical transformations, which we will cover later. But for this intro, whenever you talk about the position of something, it is literally a vector, but that vector has a well-defined tail and a well-defined head. All right? So when you say at what point is this object located, we actually answer by expressing it as a vector whose tail is anchored at the origin. Okay? Because remember, a vector intrinsically has no position. It is only a direction and a magnitude. But if we define that direction to have a tail which always starts at the origin, then the direction is useful because its direction and magnitude will take us to the location of the object.